Okay, in this video I want to talk a little bit about Arrhenius acids and bases. So let's go ahead and define what each of these are. So an Arrhenius acid is something that produces hydronium, so H3O plus, when it's in water. Okay, a base is something that produces hydroxide in water. And so depending on what we add, it could produce hydroxide or hydronium, would tell us whether it's an acid or base. So for example, if we take hydrogen chloride and we add it into water, it's going to produce hydronium. And then it's going to give us the chloride ion as well. Or if we take something like we've seen in class, potassium hydroxide, and we dissolve this solid potassium hydroxide into water, so we go ahead and we add it into water, it's going to give us the potassium ion and the hydroxide ion. So now looking at these, what we'll notice is that there's a distinct difference between these two, the way that they produce hydronium or the way that a base produces hydroxide. So notice in our first one, we could say we have hydrogen chloride, and when it dissolves in water, which is a liquid, it's going to produce aqueous hydronium and chloride ions. Whereas if we take potassium hydroxide and we add it into water, let it dissolve, it's going to give us aqueous potassium and hydroxide ions. Okay, so note we're making these two ions, right? So then we would say potassium hydroxide would be a base, hydrogen chloride would be an acid. And so if we look at these two reactions, one of the questions I asked you as part of our CC assignment was what's the difference between a dissociation and an ionization reaction. So this here is an ionization reaction. This would be a dissociation reaction. So let's go ahead and observe some differences here. So an ionization reaction creates new ions. So we'll notice as reactants, hydrogen chloride, that is a molecular compound. There's no ions. Water is a molecular compound, no ions. Well, when those two react together, they give us two ions. So this would be something we'd consider an ionization reaction, because we've gone from two molecular compounds that have reacted together to produce ions that weren't there before they reacted. Whereas we go down to our potassium hydroxide, this is an ionic compound, meaning that it's built up of an array of potassium and hydroxide ions, right? They go on and on and on and on here. So these ions are already present there. All we're doing is allowing them to dissociate or break apart into those two ions when they dissolve in water. Okay, so therefore this is a dissociation reaction. All we're doing is breaking apart or dissociating ions already present in our original compound, the potassium hydroxide. Okay, so hopefully this gives us a good introduction into acids and bases, what they are, how we identify what they are, and kind of some things to note. When we're dealing with acids and bases, we're only going to be dealing with strong acids and strong bases. So something that would be strong is something that completely does this reaction, 100% goes this way. We're going to focus on weak acids and weak bases when we get into equilibrium next semester, but this is just dealing with our strong acids and strong bases. So note for our strong bases, these are any soluble metal hydroxide. Okay, so this would be things like potassium hydroxide, sodium hydroxide, and etc., right? Lithium hydroxide. Some of these hydroxides that are soluble, okay? For our acids, there's only 7 strong acids. That would be perchloric acid, chloric acid, sulfuric acid, okay, and then we have a few different of the, then we have one more, sorry, polyatomic ion acid, and then we have hydrochloric, hydrobromic, and hydroiodic acid. And so those would be our 7 strong acids that we would see. All the other acids are weak acids. We're not going to focus on those. So we have strong and weak acids. Now let's go ahead and look a little bit about how do we talk about these acids and bases. So how do we name them? Well, if we're dealing with our bases, okay, all we're going to do is see that our name is equivalent to whatever we would name the solid ionic compound, right? So this would be NaOH. Well, that would be sodium hydroxide, lithium hydroxide, potassium hydroxide. So it's just whatever the solid compound name is. That's how we would name it. Now, when we're dealing with acids, what we're going to see is that we're going to deal with 2 broad categories of acids, and we're going to name them not the same as what our molecular compounds would be. Okay, so if we're dealing with our binary acids, so that would be some number of hydrogens with 1 element, right? So binary means 2 elements. So some examples would be like HCl, HBr, H2S. Okay, so these are binary acids, 2 different elements. So what we're going to do is we're going to take our molecular name, right? And so we're going to take the anion, right? So the chloride ion. So we're going to take that chloride ion, and what we're going to do is we're going to add in front, we're going to add hydro. Okay, so hydro, and we're going to get rid of this "ide" ending, and we're going to add "ic" acid. So then this becomes hydrochloric acid. Okay, so let's do another. Let's say we have HBr. Okay, so Br would be the bromide ion. Okay, so if we're dealing with the bromide ion, we're going to again add hydro out front. Okay, again, remember this is only for binary acids. Hydro, bro, and then we're going to get rid of the "ide" ending, and this becomes "ic" acid. So HBr would be hydrobromic acid. Okay, so when we're dealing with our oxoacids, this is going to be again some number of hydrogens, some element, and then let's call this M, some number of oxygens. Okay, so this is going to be some nonmetal. And some examples of this would be like HNO3, H2SO4, H3PO4. Okay, so these have hydrogen, some nonmetal, and then some number of oxygens. So that's why we call them oxoacids. They include oxygens here. So in order for us to name them, we're going to do it kind of like a similar thought process as the binary acids, where we're going to take, say we have HNO3. Okay, we're going to take the anion, the negative ion, and we're going to start with that. So that would be the nitrate ion. And we don't add no hydro here. Okay, so we're not going to add hydro because it's not a binary acid. We don't need to say that it has hydrogens in front like we do with our binary acids. What we're going to do is we're going to see if it ends with 8, that 8 is going to become ic acid. So this would be nitric acid. And then if we have maybe something similar, HNO2, okay, well this is the nitrite ion. Well, if we have ite, that ite becomes OUS, us acid. And so then this would be nitrous acid. So now we see, remember when we talk about naming, a name has to correspond to one compound. So we can't just have the generalization that we always make it ic acid, right? So if it ends in 8, that becomes ic acid. And then if we end in ite, that becomes us acid. And so we're replacing the 8 ending with ic acid, the ite ending with us acid. And so now we can do this with any polyatomic ion that includes oxygen for our oxoacids. Again, we start with whatever that anion is. Start with that anion name, and then we go ahead and we move forward from there. Okay, so let's go ahead and look at another one. So HClO4. So ClO4 minus, that would be the perchlorate ion. Well, now that we have the perchlorate ion, we go ahead and we get rid of the 8 ending. And so then this becomes perchloric acid. So this is important why we know what our polyatomic ions are now. So if we know our polyatomic ion, whatever that anion is, we take that name, get rid of the ending, whether it be 8 or ite, and then it becomes ic or us acid. So this hopefully gives us a good basis to kind of think about acids and bases, how we identify what they are, what kind of reactions they undergo in water, and then also how we discuss them or think about them when we're dealing with naming binary acids or oxoacids.